Good morning, leaders. How are you today? You're fine. Yeah, one thing that I can say, the class is 7 a.m., class is a repetition. It's easy to snooze the alarm than to wake up. So that is why some of my students are not here. But it's okay. It's still the beginning of the semester. And also another thing that is important. Everyone has a different plan in this class. I have my own plan. I have a certain pass rate that I have to keep. I never had less than 80% pass rate. So it's up to you if you want to win the other 20 or the 80, because 8 is going to happen either way. Some students have started consulting on the topics that we have covered. I can feel that they can start to feel the heat. This is very simple, guys. This is varsity, not high school. In high school, you had 3 terms, or sometimes even 4, to complete your textbook. Here we have 4 months. Actually, it's not even 4. I would say it's 2 complete months to finish the whole textbook. So those are 2 different environments. So if you feel like, I know that some of you now are thinking that I'm too slow because you are behind, but it's okay, we'll up the pace and we'll finish the syllabus. Don't worry about that. Because what we'll be covering today is what we should have covered yesterday, but it doesn't matter. But the principle is very simple, guys. Every day we're supposed to be doing the same, like the new thing. Every day, new thing. If it happens that you missed today's class, you missed the whole thing, you will have to study it by yourself, or you can have a consultation. This is what I get paid for. This is what I'm paying fees for, to get the education that you bought. It's all about buying and selling this thing. It's not personal. I have to do my part, you have to do your part. If you are not asking a question or you are not consulting, my assumption is that you want to move forward. You're getting it. And we're already behind, so it's good news for me that everyone is getting this so that we can move. I'm still waiting for other students to have a seat. I can't locate the twins. Where are the twins? Oh, okay. Just for you to know. I already know the faces. The only issue, I still need to know your names. It's guaranteed by me, I will know 75% of this class. But we'll see. Either based on your performance or based on the opposite of the performance. But we'll see. So yesterday, we talked about factorization, right? And we covered the greatest common factor, right? And then we covered the splitting of the middle term method, right? And we said that the splitting of the middle term method is way more powerful compared to the completing of the square. So if you know the splitting of the middle term method, it's fine. You don't need to know much about the completing the square method because it's contained inside the splitting of the middle term. You getting it? And we tried to use the understanding of the splitting of the middle term method with the difference of 2 squares to actually come up with a general formula for factorizing a quadratic equation or a quadratic expression. We saw that if, let's say, we had what's this? If, let's say, we had x squared, ax squared plus bx plus some c, we can always factorize this, right? But also, we also said that if, let's say, you want to solve this equation, you want to find the solution of this, in other words, you want to find the values of x that make this equal to 0, you can use the quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac, and then this whole thing divided by 2a. We said we can use this, right, to find the solution of this equation or to find the zeros of this expression on the left hand side, or to find the roots. You getting it? And if you can find these numbers x, you can always just say x minus that number on one bracket, on the other brackets you can say x plus that number, to actually try to factorize this whole thing, and then you have an a outside, right? What I want us to talk about today is this part here, that is this part here, which is b squared minus 4ac. What is the information that is contained there? Remember that we have an issue of a square root, right? When we're doing laws of exponents, we have that issue of the square root. You getting it? Now, if b squared minus 4ac is equal to 0, remember that when you have a quadratic equation, you're supposed to have how many roots? 2 roots, right? Not 1, not 3, just 2, right? Now, if it happens that this part is equal to 0, you will have minus b divided by 2a. You getting it? So, both the roots will be equal to minus b divided by 2a. In other words, you have one answer for 2 roots. You getting it? So, you will have 2 equal roots. You getting it? Yes. But, if it happens that this part here is greater than a 0, you getting it? So, it's guaranteed that you have a number here, and it's going to be b plus that number, that's a different answer, and then plus b minus that number, you get another different answer. So you're going to have 2 different or 2 distinct roots. You getting it? Yes. But if it happens that this part is negative, that is inside the square root, what is the square root of a negative number? Undefined, right? So in that case, whatever the answer that you will be getting, you are just imagining in your head. So it's just imaginary roots. You getting it? So you have imaginary roots. So we have 3 things: distinct, equal, and imaginary roots. We're not going to get to that more. I mean, we're not going to deal with complex numbers, as I've said before. So those are the things that are important, and I think we used to call it the nature of roots. Yes, that's the meaning behind this whole thing. Is it that important? It is important for you guys, so that when you are going back to high school and maybe you're helping grade 12 students to practice, at least you know that this is what it meant. This is what it meant. You get it? Some of the things that I'm emphasizing here will help you in the long run. Doesn't really mean that I will set them. You getting it? Yeah, especially the proofs. The proving part is not for you guys, for the math guys on our side, but for you, you need to know how to factorize this, how to solve this. That's what I'm expecting from you. How did we get that equation, big equation? It doesn't matter. What matters is how can you use it? Happy? Yes. Now, if it happens now that we have different, we have different, let me put this. Suppose that you have different expressions such that you no longer have maybe 2 terms or 3 terms. Maybe let's say you have 4. In that case, how do you end up factorizing? Where did I put my pointer? So how do you end up solving that? How to end up factorizing in that case? I'll say it. So if it happens that you have that, how do you end up factorizing? Because let's say you are looking into this part. You are looking for this part here. You know that you can always use the difference of, the splitting of the middle terms, isn't so? And if you are dealing with this part, you know that you can use the splitting of the middle term, or where did I put my point? Just disappeared. You can use the splitting of the middle term, or you can use quadratic equation, or you can use completing the square method. Thank you guys. And if you have this part here, you can use a difference of 2 squares, because you know that this is the same as x squared minus y squared. And then you can manipulate this using the difference of 2 squares. But now, with the methods that we already have, can we be able to factorize this? That's the question. Can we? How will we go about factorizing this? The splitting of the middle term. What are the rules for the splitting? We had 3. The first one, we must have how many terms? How many terms do we have here? So we can't use the splitting. What else can we use? Do we have a common factor here? So with the methods that we already have, we cannot factorize that. Which means we need to move a little bit further and find a different factorization method. Right. Now, when I'm factorizing a cubic, this is my personal it's a personal method that I like myself. The one that I like is, you can say deriving, is inspection, factorization by inspection, or others call it trial and error method, right? Some students, they like long division. You getting it? It's fine, you can use any of these methods. For me, it's just personal to me that I like inspection. So with that in mind, I want us to look at other factorization techniques that you can use in such cases. Right. Now, what are these other techniques? Right. As I said, is you can use long division, you can use inspection, or you can use binomial theorem. Binomial theorem, I know that you have done what is called the Pascal's triangle. So the Pascal's triangle is included, just a special case of the binomial. You know it? Yes. So we can use those 3. If they fail, which means we need to try something else, or we need an assistance of AI, or you need a computer to solve some of these things. But for us, our emphasis will be on factorization by inspection and long division. You getting it? Yes. And then, when can we use a long division and factorization by inspection? The first thing that you have to note is that at least you must know one of the possible solutions, or one of the possible values that if you plug it inside the equation, it will give you a 0. So those 2 you can only use in such case. But even though that might happen, if n in that equation, their polynomial, is way too large, let's say 5 or 6 or 10 or 100, then doing this becomes tedious. I mean, you might end up taking the whole day trying to factorize one thing. So in those cases, it's not advisable to use these methods. You getting it? Yes. So, looking into this, binomial theorem can only be used if when you look at the coefficient in front of the variables, they follow a binomial expansion. You getting it? This, you will usually use it more in stats. So, let's look at these special cases. If you notice with the first one we did prove this using splitting of the middle term. But what we're trying to do was to find the factorization of the difference of this, of that, right? And then now, because you know, we used the splitting of the middle term, that this is equal to that, so you can use this. You got it? And when it comes to also this one, you can prove this to using inspection. You got it? You can use that. But now, I'm just giving you for free, you can use them. You got it? You don't have to prove them. You just have to know them by heart. You got it? Yes. Others is the binomial theorem. The binomial theorem is saying that if you have x plus y inside the brackets, carrying it, and all raised to a 1, this is the same as x plus y. You getting it? In other words, you have a 1 in front of x and 1 in front of y. And then when it comes to x plus y whole squared, what does that supposed to mean? It means that you will end up having x to the power 2 plus, what is 1 plus 1? 2. So you're going to have 2xy plus a y squared. You got it? Yes. Basically, what is basically happening here is this. Let me show this. So, first you had x plus y to the power 1, and we said that this is x plus a y, right? Now you have a 1 here, you have a 1 there. You getting it? Now when it comes to, you are going to x plus y squared, which is this. All you need to do, the first term will have a squared, and then when it comes to the second term, it's gonna be this 1 here plus that 1, you get a 2, right? And then you look at x, this 2 here, the next x will have a 1. You're getting it? So you are reducing in that particular fashion. While you are reducing in that particular fashion, the exponent of y is growing. You're getting it? Now, when it comes to number 2, you have a 1 here, you have a 2, you have a 1 there. So you have a 1. What is 1 plus 2? Is 3. So the next one here will be a 3. You getting it? Yes. And then when you look at this 2 there and this 1, what is 1 plus 1? I mean, what is 2 plus 1? Hence you have a 3 there. And then you keep x cubed and y cubed. And if you were to go to x plus y to the power 4, what you are going to get? You are going to get x to the power 4 plus, right? Now, what is 1? There is a 1 there. 1 plus 3 is, so you're going to get a 4. Let me put xy at the moment, right? And then after that, if you take, what is 3 plus 3? So you're supposed to have a 6 there. Let me put xy for now, right? And then, what is 3 plus 1? So you're supposed to have 4, let me just say xy for now. Plus, the last term is supposed to be y to the power 4. Do you get it? Now, you have a 4 there. The next one is supposed to be, x is supposed to be 3.
x is supposed to be a 2, x is supposed to be a 1, and here you have x equal to a 0. You getting it? And then when it comes to y, you had a y here, which had an exponent 0. Y to the exponent 0, you know that is a 1. So multiplying that is not going to make any difference. So it's 0, and then you have a 1 there, you have a 2 there, you have a 3 there, and then you have a 4. And then you go in that particular fashion. Now, when you were doing Pascal's triangle, you were actually following this principle. You getting it? But in general, this is how the formula looks like. Thank you. We're not going to prove that. You can try and prove it. Yes, ma'am. Not following. Okay. What I'm saying is this. Yeah. What I'm saying is this. If let's say you had, what's this thing now? Yeah. I said if you have x plus y to the power 1, how do you expand that? This is the same as 1x plus 1y. You're getting up to this far. Which means that when you are seeing this thing here, it means that you can factorize it like this. You getting it? The second thing I said, if you have x plus y to the power 2, how do you expand that? To expand it, it means that this is going to be, you have a 1 here, you have a 1 there. Take note of that. But you're still going to have x, what is this? You're still going to have x squared. So you're going to have your x squared there. And then the second term is going to be 1 plus 1. What is that? You're going to have a 2. I said, for now, let me put an x and y because I have an x and y inside. And then, what will be the last term? You're going to have your y squared. You're getting up to this one. Now, I am saying that here you have a 2. You want to look for the exponents of the x's throughout. Yes. It's an expansion, yes. That's what we are doing. We have a 2 there. The next term will have x to the power, the previous term minus 1. So you're going to have 2 minus 1. Here you will have a 1. Right. And then the following one is supposed to have x to the power 1 minus 1, 0. What is x to the power 0? It's 1. That is why it's not there. You getting it? Yes, that's what I said. Yes, ma'am. This part. Let me write this. You mean this part? Where's this one coming from? Oh, this one is this one and this one. We are adding them. Let's do the next one so that you will see. Suppose now I'm saying you have x plus y to the power 3. First, you're supposed to have x to the power 3. You getting it? Plus. Now, there is a 1 here. Let me change the color. There is a 1 here, and there is a 2 there. What is 1 plus 2? So you're going to have a 3 there. And then I said, let's put xy for now. Plus, you have this 2 here, you have a 1 there. What is 2 plus 1? You have a 3. Let's put xy for now. Is there anything else to add? No, which means we need the last term, which is y cubed. Now let's look for the exponents. The exponent is, we had a 3 there. What is the next one should be? a 2. What is the next one? The next one, even if you don't put it there. Now let's go for y. Right. Y here started with a 0. When x is going this way, y is going that way. You getting it? So we have 0 here. What will be the exponent of y here? 1. Here. Here. Thank you. Are you getting it now? Yes, that's what I was saying. Okay. Let's go back to where we were so that we can do some exciting stuff. There's some exciting stuff here. Yes. Now, I said that we dealt with this part, we dealt with this part, and now we are going for the negative. The negative part, look at the negative part, I didn't mention that. If you notice what we're doing, the only thing that is happening when you have x minus y, the sign keeps alternating. That's all there is to it. It's plus, minus, plus, minus, plus, minus. That's all there is to it. Nothing fancy. That's all there is to it. You have to know this by heart. Thank you. Now, how does this factorization by inspection actually work? I want us to look into that. The first step is very simple. You look for the last term. Look at it and smile at it and like, I'm going to get it. And then you look for the factors. If you don't smile at me, it's not going to smile. But if you're smiling, you're like, okay, let me give you the answers. It's the only thing that is true in this science. Mathematics never lie unless you are forcing it to lie. It will tell you the truth. That is why mathematicians are always known to be logical. I love this person, but why? Why do I just love this? That's how the logic is. And then you find someone running away from you. It's not like they don't love you back. It's the maths that is blocking the love. They want to listen. So that's where this thing comes in. But of course, love and logic, they don't go hand in hand. You have to be stupid to be happy. So now that you have this, you guys are lying to each other. You don't have to solve anything. You lie to each other. You know what? I have a class. I don't have a class. I have a class. No, I'm trying to run away from you. Simple. But I'm trying to be polite as possible. I have a class. I have to go to do that. It's not personal, guys. I'm not supposed to usually say, oh, something like that. Yeah, something like that. But that's what is basically happening. Don't take it personal. Find the factors of the last term. What are the factors of plus 8? I did not say 8. I said plus 8. Like we were doing the middle term thing, the splitting of the middle term. I know what you know. The reason I'm going the way that I'm going, I'm giving you a generalized way of solving things. You are used in solving x alone. You have x squared minus x, or 2x plus some constant. You are used to that. That is why when you're factorizing, we're only focusing on the coefficient. What is the coefficient of this? Multiply this. If they give you this, it's because you were only focusing on coefficients. Here, I'm focusing on the whole thing. What if you don't have one variable? Will you be able to deal with that? Because you still want to know what will be these terms in the middle. You getting it? Yes. But you can always round it off to what you know. But you need to know what I taught you. Now the first thing, find the factors of plus 8. What are the factors of plus 8? Plus 1 and minus 1. Second one, or the third one, plus and minus 2. Isn't so? And then the third one is plus and minus 3. So 3 is not going to 8. Thank you. So the next one is plus or minus 4. And then the next one is plus or minus 5. Right? So 5 is not going to 8. Okay, the next one is plus or minus 6. Thank you. 6 is not going. But the truth of the matter, guys, that's how you go about this. Don't just
Start with 1 and go all the way until you arrive to 8. You getting it? That's how you go about this. So the factors of 8 is supposed to be, these are supposed to be the factors. You getting it? Now, what is the next step? Take each of the factors, plug it in the expression and see what you are getting. That's the second step. If I'm plugging in the, let's say I'm plugging in the -1. These are the answers that I got. You can check them, guys. I don't usually use a calculator. It might happen that I made a mistake. You can check them. So you have, if you plug in -1, you will get this. If you plug in 1, you will get that. If you plug in -2, you will get that. These are all the things that you will get. Remember that you are looking for a factor that will give you a 0. What is the first factor that is giving you a 0 there? -2. So this is what you do. Now that you are here, all you have to do is this. You have your x here, right? You said it is -2. Change the sign of -2. What is it? So it is plus a 2, right? If you have a cubic and then you reduce the power by 1, what will you get? A quadratic, right? How many terms does a quadratic have? 3. So in the next bracket, you're supposed to have 3 terms. You getting it? The first term is, you're gonna take 3x cubed divided by x. What do you get? 3x squared. The last term would be plus 8 divided by plus 2. You're gonna have a plus 4. The middle term, what is it? We don't know. We don't know. It is some constant a or m times x. You getting it? But because we are factorizing this has to be equal to 3x cubed minus 2x squared minus 12x plus 8. You getting it? Yes. The next step is expand the left-hand side alone. Leave the right-hand side as it is. If we are expanding the left-hand side, what are we going to get, guys? I'm trying to create a space so that I can write. I'm not sure if I will get some. Okay, I'm not getting anything here. Forget about this. I only myself know what's going on here. It's going to confuse you a lot. Just focus on what we are doing here at the moment. Now, once you have this part, if we expand this, we're supposed to multiply this with that. What are we getting? 3x cubed. And then multiply this with that. What are we getting? Plus ax squared. If I multiply this with that, what will I get? Plus 4x. And now I multiply this with that, what will I get? You're gonna have, where's this thing? I want this. Plus 6a, is it 6a squared? 6ax? 6x squared, that's what you're saying. Okay, let me try and wrap this. Seems like I'm good at writing nonsense. This is how mathematicians think. If they can write on top of it, maybe you will see it. So you have 6x squared. And then what do you have? This with that. Plus 2ax. And then this one with that. Plus 8. That's it. Okay. Yes, ma'am. Oh, if you multiply x times 3ax squared, what do you get? X times 3x squared.
you're still gonna have, there's a 1 there. 1 times 3 is a 3. This part, oh, thank you. I said that you take this 3x squared, you divide it by x. What do you get? 3x squared. And then you take plus 8, you divide it by plus 2, you get a 4. And then this part, you don't know. You just assume it's some number a. You don't know it. We want to find it. That's why we're expanding. Okay. Now that we have this, how many terms here that have an x squared? What are they? It's ax squared plus 6x squared. Now, because these things are on the left-hand side, they're supposed to be equal to whatever is on the right-hand side that have an x squared. You getting it? So, this is supposed to be, what is on the right-hand side that have an x squared? Minus 2x squared. Do you get it? Do you think we can solve for a if we have this? Okay, first factorize ax squared minus 6x squared and see what you're getting. What is the factorization of this? It's gonna be, you're gonna have a plus 6 times x squared. Did you get it? Now you have an x squared to this side, you have an x squared to this side, which means whatever this number is, it should be equal to minus 2. You getting it? So you're gonna have a plus 6 is equal to minus 2. Can you solve for a now? Can you? What is the value of a? So your a is minus 8. So here you're supposed to have a minus 8. That's what is basically happening. This is what you are seeing here. This nonsense here is just saying, okay, you have this, you solve, and then you have this nice thing here. That a is minus 8. Now the question is, can you factorize this part? Can you? I want us to factorize that by inspection also. How do we factorize by inspection? The first step is find the factors of the last term. That's the first thing. What are the factors of plus 4? It is minus 1, plus or minus 1, and plus or minus 2, and plus or minus 3, and oh, it's a 4. I'm the only one who's drunk in this class. Okay, it's fine. Now, which of these terms, if I plug it here, I will end up getting a 0. Let's plug in minus 1. What is minus 1 squared? Times 3 plus 8 plus 4. Are you getting a 0? If we plug in a 1 there, what is 3 minus 8 plus 4? Are we getting a 0? Okay. Let's plug in minus 2. What is 4 times 3? 12 plus 16 plus 4. Is it a 0? Okay, now let's say, what is 4 times 3? Minus 8 plus 8 plus 4. Okay, I'm kidding. If let's say you plug in a 2 there, a positive 2, what are you going to get? 0, which means here you're going to get x minus 2 because you changed the sign. And then, once you remove 1x in a quadratic equation, what are you left with? Linear, right? If it is linear, how many terms does it have? 2. How do you get the first term? You take the first term, which is 3x squared, and then you divide by x. What are you left with? 3x. How do you get the last term? What is plus 4 divided by minus 2? Minus 2. How many terms does a linear have? So you don't need the middle term there. You are done. You see how easy it is?
It's not that hard. It's not that hard at all.
Do you get it up to this far? This is what I did. It's also the same thing, and you are there.
Now, when it comes to the long division, guys, you can try it. You can just try it. It's not a biggie. We are still going for the inequalities. Inequalities are very nice, guys. Yeah, inequalities are very nice. I've seen this thing, especially we guys and women and kids and everyone. No, we're equal. We're equal. Everyone is trying to be equal. Others are feeling unequal. So that's where inequality comes in. To see which one is bigger, which one is it's not big. When I was raised, I was always told that the guy is the head of the house. You are the head, okay. If you are a head, you need a brain, which means the woman of the house is the brain of the house. No! Guys, come on.
Let's focus on this. Now, are you okay with factorization by inspection first?
Are you okay with splitting? You're not okay? These are the steps, guys. Don't make this thing harder than it is. Don't, please. I said the first step is take the first term, multiply it by the last term. You get an answer or just say the product. Leave the product as it is, nicely sitting there and smile at it. I got it. After that, you want to find the factors of the product. Of the product. Such that when you add them, they give you a middle term. Is that hard? It's not hard at all. It's not. That's all you have to do, guys. That's all. If you still want more questions, you'll have so many questions in the chat and you'll be solving questions. That's why we're not doing more of the questions here. You got it? Okay.
Now we have built our calculus a little bit, but we're not yet there. The class is supposed to end in 5 minutes. Okay. I want to use this for something else.
Well, built our calculus, fine. You know that when you're dealing with functions, you will be able to deal with the functions if you know how to factorize. Right? You know now that you have to factorize. But when you have a function, you have to plug in inside the thing so that you can get something. You must have an input. An input must be a number, right? It must be a number that you're plugging in the function so that you get another number. You getting it? So now we need to have a set of numbers that we're going to use to build this calculus. You getting it? Yes. And in order for us to say this set that we have is good, whenever I pick two numbers inside, I should be able to add them and get a number that is still inside the set. You getting it? And whenever I pick two numbers and subtract them, I should be able to get a number that is still inside. You getting it? If I pick a set of integers, for instance, when I'm adding integers, I should be able to say, I got a number that is still an integer. If I take two integers, I subtract them, I should be able to get an integer. You get it? That's what I mean. If I multiply them, I should be able to get something that is still inside the set. If I divide them, I should be able to get a number that is still inside the set. So we have these four operations: addition, subtraction, and multiplication and division. Those four, they must be satisfied. So when this whole thing started, you started with it, I think you were doing grade 1 or 2 or grade R, depends on the school that you're in. You started with some counting of numbers. And when you were counting them, you had 1, 2, 3, 4, 5, 6, 7, up to maybe 10 or something. But those numbers, we usually call them the counting numbers or integers. And the symbol is this nice N there. But if you add them, you will be able to get another natural number, right? If I subtract them, am I always going to get another natural number? If I say, let's say I pick 1, I say 1 minus 2. What is 1 minus 2? Negative 2 is not contained there. So we cannot use natural numbers. Right? We want something bigger, but it must contain the natural numbers. You getting it? So with that, we say, okay, let's try and have a set of integers that have a negative of these numbers because the issue was negative. You getting it? And if you look into that, when you're adding integers, you'll still get another integer, isn't so? Multiplying them, you're still going to get another integer, isn't so? Subtracting them, you're still going to get another integer, isn't so? But the issue is when you divide them. If I take 1 and I divide it by 2, will I get another integer? So I need a bigger set than that. So I say, okay, let me move on and choose rational numbers. Rational numbers are real numbers first. That can be written in a fractional form with both numerator and denominator integers, such that the denominator is not equal to 0. But if you look into this, all the integers are contained inside the rational number. But wait a moment. If I decide, for some reason, like, okay, I want to see this. How is it going to boil out? I want to deal with functions. But if I have a square root inside there, all these four operations can be satisfied, right? But the issue that we have now, let's say you have x squared minus y is equal to 0. Can you be able to solve that and get an answer that is still inside the rational numbers? You can't, because the square root of 5 is not a rational number. So we need another set. But when we are going for irrational numbers, the issue is that irrational numbers does not contain rational numbers. So we need a set that will contain the two. That is why we end with real numbers. Real numbers are the numbers that we'll be able to use because we get inside. Thank you very much.